Everyone. So for my geography students, we are looking at river erosion and the four processes that are a part of river erosion, namely hydraulic action, corrosion, and attrition. All right. So we have these four processes which all work together in order to erode the river, or in order for river erosion to occur. All right, so we have hydraulic action, which is hydraulic pressure. That is the water pressure. Water has a lot of pressure, okay? And so that pressure is contained in this hydraulic action. So what happens is water and air is trapped within the rock. How is it trapped? How does it get trapped in the rock? It is forced into the rock because the rock has cracks. So there are cracks in the rock which create an opening for the water to flow into the rock, creating pressure which breaks the rock apart. So I want you to imagine, let's say you are blowing air into a balloon. Now, we all know, back in our childhood, that if we blew too much air into a balloon, it would burst. Now, I want you to think of the air you're blowing into that balloon as the water that's now flowing into the rock. So, of course, the balloon bursts, but the rock will break apart. Good. So that's hydraulic action. And a visual representation of what I mean is this. As you see there, initially, we have some cracks there. We have some cracks, okay? We have some 3, 4 cracks there. And then there's water just moving in. And over time, it's moving in much more deeper, okay? And then eventually, we have 4 fragments of the original rock. That means the rock has broken apart into these fragments over here. And so that is hydraulic action, which deals with the hydraulic pressure or the pressure of the water. Hydraulic action. Very, very good. All right, so we move on to corrosion. Now, corrosion happens when the load carried by the river. So the load are all the rocks and sand and stones, because we don't just have water in a river. We have the rocks, the sand, because this is water that travels, that moves every single minute, and it takes something along with it. It takes rocks, it takes sand, because it moves through the valley, okay? Which is rocky terrain, which is full of rocks and sand, and it's through mountains, okay? And so corrosion happens when the load, that being the rocks, the sand that I'm talking about, that's been carried by the water, by the current of the water, the load carried by the river scrapes against the sides. So the sides, let's say, here my hands, these are the sides, and the bottom of the valley. So we have the bottom, and then we have the sides. Now, imagine that this is my valley. Okay, this is my valley, and it has a V shape, right? Now, the scraping causes the valley to widen, and then we have a shape like that. So initially, it was V-shaped because valleys are V-shaped, but then over time, it widens and deepens. So in a much more better visual representation, because I know my hands won't do much, uh, that is corrosion. As you can see, the black shows the V shape of the valley. Now the blue shows us that these stones, which are the load, are corroding, creating that shape, and over time we have something like that. And that is corrosion. Not to be confused with corrosion. O-A. Okay, make sure you get that difference stuck somewhere in your noggin. It's very important. Good. So that is corrosion. Okay, so the bottom and the sides of the valley are corroded. Excuse me, not corroded, but are eroded, because corrosion is here. Okay, that's a different story. So are corroded, which means this part and that part of the valley will break down as a result of the pressure and also of the load, and that results in that shape we have there, where the valley is wider and deeper. As you can see, it's much more deeper than initially, and it's wider. Okay, so that is corrosion. Now we move on to corrosion. So corrosion, and don't you worry, I will of course have pictures taken of these notes, so you guys can always copy these notes. I think it will be of a great advantage to you guys. I just don't get why my picture is okay. Hopefully it will stay that way because it's been darkening every minute now. Good. Corrosion happens when chemicals in the water dissolve into the rocks and weaken the structure. So corrosion should not be confused with hydraulic action. Hydraulic action, we have water and air that acts on the rock to break apart the rock. With corrosion, as I've indicated, so we have red and we have blue. So the blue symbolizes the water that's flowing into the rock, and the red are the chemicals. So these chemicals are dissolved in the water. Okay, so these chemicals are dissolved in the water, and as water goes into the rock, so do the chemicals, and eventually, over time, these chemicals will weaken the structure of the rock. They will make the rock soft. Okay, here it's not about the rock being softened. Here it's the rock being broken apart under hydraulic pressure. Hydraulic pressure is the same thing as hydraulic action. All right, but here it's chemicals that are weakening the rocks, and eventually the rocks will get softer, weaker, and will break apart. And then we have that red and blue to show you that there's now chemicals within the rock and it's going to break apart eventually. Good. So that is corrosion. That is corrosion. Now we can move on to attrition. Now, attrition, that's the last process. Here, the boulders that form part of the load, boulders are very big stones, very huge stones, okay? These continuously rub against each other, breaking down into stones and sand. That is attrition. So with attrition, what happens is this. So you have your big boulders over there. They are rubbing each other, and they rub, and as they rub, small pebbles and stones begin to fall from that mixture, and they continue rubbing, and you see they get smaller in size. They were bigger there, they're smaller, and they grow smaller because they're rubbing each other, and eventually they're just now pebbles and stones and sand. That's what attrition is. It's basically just two stones just rubbing, and over time they crumble and they break, and then you have those stones and sand over there. So that is attrition. So it's a gradual breakdown of the load, if we can put it that way. It's a gradual breakdown of the rocks and these huge boulders that are a part of the load. So that's your hydraulic action, your corrosion, your attrition, and your corrosion. Very well.